In this lesson, we will look at Unit 2, Section 2.4, the sine and cosine ratios. In this lesson, you will learn how to develop and apply the sine and cosine ratios to determine angle measures. In the previous lessons, we looked at the tangent ratio, which can only be used when given the opposite and adjacent sides. The hypotenuse is not applied in the tangent ratio. Sine and the cosine ratios. In a right triangle, the ratios that relate each leg to the hypotenuse depend only on the measure of the acute angle and not on the size of the triangle. These ratios are called the sine and cosine ratios. First, the sine ratio. If angle A is an acute angle in a right triangle, then we can write sine A equals opposite divided by the hypotenuse. In a similar way, the cosine ratio will be written cos A equals adjacent divided by hypotenuse. Again, if angle A is an acute angle in a right triangle. If sine A equals 0.5, then in any similar right triangle, the length of the side opposite angle A is 0.5 times the length of the hypotenuse. If cos A equals 0.7, similar to the sine ratio, the length of the side adjacent to angle A will be 0.7 times the length of the hypotenuse. So keeping in mind that it doesn't matter what the decimal is when you're talking about the sine ratio. The length of the opposite side will always be that decimal or that number of times the hypotenuse. And in cos, it will be the adjacent side that will be that number of times the hypotenuse. So refresh again. Sine A equals opposite divided by hypotenuse. Cos A equals adjacent divided by hypotenuse. So now we have the primary trigonometric ratios. When we talk about the sine, the cosine, and the tangent ratios, the three of those ratios will comprise the primary trigonometric ratios. These ratios are used to determine the measure of missing angles and sides depending what is given. In any triangle, if measurements of two angles of the triangle are known, the measure of the third angle can be calculated since the sum of the measures of the angles must equal 180 degrees. So if you were given a right triangle where two angle measures are known already, the third one, it can be simply found by going 180, subtract the two known angle measures to find the missing one. Or you can add up those two angles first and then take it away from 180. You have to keep in mind that all three angles of a triangle will add to give 180 degrees, and it cannot go more than that. So the third angle can be found by simply subtracting from 180. The Pythagorean theorem can be used to find the length of the third side of a right triangle when you know two given sides already. So simply use Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. And you can change or rewrite that formula to meet the need that you have or to help you find the side that is there. So first of all, using the sine ratio. We can use the sine ratio to help us find a missing angle, similar to this question in this example. We're given legs 4, we're not given another one, and we're given the hypotenuse 7. So labeling this triangle according to theta, we have an opposite of 4 and hypotenuse of 7. which will give us sine theta equals 4 divided by 7. We're going to write that as a decimal, so it's going to give us sine theta equals 0.5714, and that will continue on. When we need to find the angle measure, we'll have to use the inverse function of the trig ratio given. So we have the inverse function of sine of the decimal, and it will give us approximately 35 degrees. In summary, we have our three trigonometric ratios now: sine, cosine, and tangent. So if you want to have something easier to remember these ratios by, you can think of it as SOHCAHTOA. SOHCAHTOA. And to make it a little easier on yourself, you can make up a little rhyme that helps you to remember the letters of SOHCAHTOA for sine, cosine, and tan. And one of those would be: silly old horses can't afford houses till old age, which will give us sine, opposite and hypotenuse, cosine, adjacent and hypotenuse, tan, opposite and adjacent. So whenever you're given a question where you have to find the angle measure or the side measure, it's a good idea to write SOHCAHTOA at the top of your page, so it will help you to identify what ratio meets the needs of the question.